The universe is ever expanding, revealing new aspects of its enigmatic and awe-inspiring nature. A major breakthrough occurred in 1929 when scientists discovered that the cosmos itself is expanding, a realization that fundamentally altered our perception of how the universe has evolved over time. This discovery did more than reshape astronomy, it challenged humanity's place in existence, forcing us to think beyond the borders of our planet. As our comprehension of the cosmos grew, we uncovered a more profound truth: the atoms in our bodies originated within ancient stars. By 1957, scientists understood that the beauty of the night sky was more than a visual spectacle. It was a living, dynamic manifestation of immense and powerful forces shaping the universe, a cosmic dance of birth, death, and rebirth that has been ongoing for billions of years. The cosmos is in perpetual motion, filled with activity and riddled with mysteries we have yet to fully grasp. Galaxies drift apart at accelerating speeds, planets orbit their stars, and entire clusters of galaxies form and merge across incomprehensible distances. This ceaseless activity raises enduring questions about our existence, why we are here, how stars and planets form, and what alternate paths the universe might have taken had the laws of physics been slightly different. Human beings have always looked upward with wonder, but our curiosity is often reactive. We tend to take an interest in cosmic events only when they pose a threat to us or stir significant concern about the fragility of our world. It is only when comets streak unusually close, or asteroids are rumored to cross Earth's path, or when a star shows signs of impending transformation, that our fascination with the sky deepens. One of the most captivating examples of such cosmic uncertainty is Betelgeuse, the giant star in the Orion constellation. Recently, it has shown unusual signs of instability. Its behavior has stirred both excitement and anxiety within the scientific community and among the public. Betelgeuse is no ordinary star. It is a red supergiant of immense proportions, vastly larger and more powerful than our Sun. Despite being located more than 640 light-years away from Earth, Betelgeuse shines so brightly that it appears as a brilliant red point in the night sky, easily visible even to the naked eye. This brightness is deceptive, however. The distance means that the light we see tonight actually left the star more than 6 centuries ago, long before many of the civilizations we know from history even existed. To put its scale in perspective, if Betelgeuse were placed at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, and Mars entirely. Stars may appear calm and unchanging from our perspective, but in truth, they are restless entities. Betelgeuse in particular has fascinated astronomers for centuries because it is what is known as a variable star. Its brightness changes dramatically over time. This is due to the way it expands and contracts in massive cycles, as if it were breathing. Its brightness can shift from magnitude 0 to 5, making it one of the most volatile stars visible in the night sky. These changes are not random, they follow recognizable cycles, with one shorter cycle lasting around 185 days and a much longer one stretching over 2,300 days. By meticulously observing these cycles, astronomers gain critical insight into the star's internal mechanics and the processes that drive its instability. In February 2021, astronomers observed Betelgeuse at one of its dimmest points in recent history, measuring just 1.16 in the V-band. For a star of such prominence, this drop in brightness was startling. Its deep red glow added to the mystery. The red coloration comes from its relatively cool surface temperature, around 3,500 Kelvin, much cooler than our Sun's blazing 5,500 Kelvin. Because of this cooler temperature, each patch of Betelgeuse's surface emits less energy compared to the Sun, but the star's sheer size means it still outshines most others in the night sky. Despite its brilliance, Betelgeuse's instability is cause for concern, suggesting that it may be approaching the later, more turbulent stages of its life. Like all stars, Betelgeuse generates energy through nuclear fusion, the process by which hydrogen atoms fuse into helium under extreme pressures and temperatures in its core. For most of its life, this process remains steady, creating a delicate balance between the outward push of energy and the inward pull of gravity. But in red supergiants like Betelgeuse, this balance eventually breaks down. When the hydrogen in the core runs out, the star begins to fuse helium into heavier elements such as carbon and oxygen. Unlike hydrogen fusion, this process is far more chaotic, producing irregular bursts of energy that destabilize the star's structure. The outer layers begin to swell and contract, causing powerful stellar winds that eject massive amounts of material into space. This instability gives Betelgeuse a heartbeat, a rhythmic cycle of expansion and contraction that can be seen from Earth as fluctuations in brightness. To study these pulsations, scientists rely on photometry, the precise measurement of light, and spectroscopy, the analysis of light across wavelengths to determine temperature, composition, and motion. Together, these tools act like a stethoscope for the cosmos, allowing astronomers to listen to the star's pulse and decode its secrets. The data are then fed into complex computer models that simulate the star's behavior using the principles of fluid dynamics, thermodynamics, and nuclear physics. One of the most significant processes inside Betelgeuse is convection, the constant circulation of hot plasma rising to the surface while cooler material sinks back inward. This process transports energy outward, but in such a turbulent environment, the flow is uneven. At times, more energy reaches the surface, brightening the star. At other times, less energy escapes, causing it to dim. These shifts, though appearing random, reveal patterns that scientists are learning to interpret as clues about the star's ultimate fate. Eventually, Betelgeuse will exhaust all of its nuclear fuel. When this happens, gravity will overwhelm the outward pressure from fusion, and the core will collapse in an instant. The result will be a supernova, a catastrophic explosion so bright it could briefly outshine the entire galaxy. While this finale is likely thousands of years away, it is a fate astronomers are eager to understand, because it is both destructive and creative. The explosion will scatter heavy elements such as oxygen, iron, and carbon into space, seeding the next generation of stars and planets. Indeed, the iron in our blood and the calcium in our bones were once forged in the heart of long-dead stars like Betelgeuse. In this way, its story is deeply connected to ours. Betelgeuse is not just a mystery but also a valuable natural laboratory. Unlike our Sun, which is expected to live more than 10 billion years, Betelgeuse is relatively young, probably only 10 million years old. Its enormous mass, however, has forced it to burn through its fuel at a much faster rate, pushing it toward the end of its life far more quickly. By studying it, astronomers gain insights into how massive stars live and die, and what role they play in shaping galaxies. One of the most striking recent events in Betelgeuse's history occurred between late 2019 and early 2020. Known as the Great Dimming, it saw the star's brightness drop to its lowest recorded level in over a century. At first, many speculated this might mean Betelgeuse was about to explode as a supernova, a prospect that generated worldwide excitement. However, follow-up studies with the Hubble Space Telescope revealed that the dimming was likely caused by a dust cloud. Betelgeuse had expelled a large amount of material, which condensed into dust and temporarily blocked its light from reaching Earth. The incident highlighted the violent and unpredictable nature of red supergiants, as well as the importance of constant monitoring. Although Betelgeuse eventually returned to its usual brightness, the Great Dimming left astronomers with a valuable case study of the processes that lead up to a supernova. The ejected dust cloud served as a reminder that stars are not fixed, eternal points of light, but dynamic, living systems subject to change. In a sense, we are watching Betelgeuse's final chapters unfold, knowing that its ultimate explosion will one day transform the skies and enrich the universe with the elements of life. Understanding Betelgeuse also gives us a glimpse into our Sun's distant future. While the Sun is not massive enough to end as a supernova, it too will eventually expand into a red giant, engulfing the inner planets and shedding its outer layers before settling into a white dwarf. The lessons learned from Betelgeuse help us anticipate how that process might unfold, even if on a less dramatic scale. A newer field of research, called astroseismology, is becoming crucial in this effort. Similar to how seismology uses earthquakes to probe Earth's interior, astroseismology uses the oscillations and vibrations within stars to study their inner structure. For a star like Betelgeuse, this method provides an unprecedented look into its density, composition, and the flow of energy within its vast convective layers. Each flicker of light, each spectral shift, and each oscillation carries information about its internal dynamics. Betelgeuse's story is still being written, but already it has transformed our understanding of stellar evolution. It reminds us that even the most distant points of light in the night sky are dynamic, restless, and essential to the cycle of creation in the universe. Its instability is not a sign of weakness but of transformation, a signal that it is nearing the end of one stage and preparing for the next. For humanity, this is both humbling and inspiring. It connects us directly to the cosmos, reminding us that our origins lie in the death of stars and that our future may also depend on them. The universe is vast, mysterious, and ever-changing, and Betelgeuse is one of its most fascinating beacons. It is a reminder that the night sky is not static, but alive, filled with stories of creation and destruction unfolding across cosmic time. By studying it, we learn not only about the life cycle of massive stars but also about ourselves, our past, and perhaps even our future.